All right, so last time we were doing systems of equations, and I gave you some problems to look at, right? So were there any questions on those problems to start? Did anyone have any questions on those? Where are they? No? Have y'all started them? Yeah. No? Okay. All right, so why don't we just do a problem to get us going, just to kind of warm up, and then what we're going to do today is word problems, all right, that have to do with systems of equations. I did one with the mixture problem last time. We're going to do more of those, and then on Thursday we're going to talk about the exam, which is on Tuesday, a week from today. So I will provide you a review for the exam within the next day or so. Hopefully you can look at it before Thursday and come with any questions. So Thursday will be a little bit of lecture, a little bit of review. Come in on Tuesday, take the test. And then I think we only have a few classes after that, right? We have the 26th is our test next week. So after that, we'll have 3 class meetings and then we'll have our final exam. So technically we have today, Thursday, next Thursday, Tuesday, Thursday. So what's that, 5 classes left? Okay. All right, so here we go. I'm actually pulling out of the packet right now. We have a couple of systems of equations here. And I thought we would start with, well, let's do number 3. Let's do number 3. All right, so I'm going to copy this down. Maybe. Y'all seem quiet today. Are y'all all right? Everyone's good? All right, so we're trying to solve this system of equations. And I don't know, we had 2 methods, right? We had, what were they called? Substitution and elimination were the 2 different methods we had to do this. So substitution, let's just kind of run through the steps. Substitution, we would look at the equations, we'd solve one of them for either X or Y. I said Y. And then we would do this thing where we plug that into the other equation. And we like that, I guess, a little bit. And then I showed you elimination. Everyone was like, let's do elimination pretty much, right? So let's go with elimination here. So the goal of elimination is to look at the X's, see if you add them down if they go away. Look at the Y's, see if you add them down if they go away. And here, neither one would go away, right? If I add down 2x minus 6x, that's negative 4x. That doesn't go away. Negative y and 3y, add that down, you get 2y. We want it to add up to be 0. So we're going to have to tweak it, right? So what do y'all think? Y'all want to go after the X's, make these cancel? You want to go after the Y's? What's easier? Y? I heard both X and Y. How would you go about getting rid of the X's? What would you have to do to get rid of the X's? You could multiply this 2 by a 3, right? And then it would become 6x minus 6x, and they would cancel. So if we try and cancel the X's, we just multiply by 3 across the top. How would you multiply, or how would you get these to cancel if you go after the Y's instead? The same thing, right? You would multiply by 3, this would become negative 3y, you add down, you get 3y and negative 3y add up to be 0. So it looks like they both would achieve the same thing. So let's go with multiplying by 3 on top. So I'm gonna put a 3 here, and just remember that 3 must distribute through to everything. And this will create a new system of equations. What is my top equation? What does it become? 6x, okay. Then what? Minus 3y. And then equals the other side, 15. And then on the bottom, we just leave it, negative 6x plus 3y equals 7. Okay. So we did what we need to do, right? Now let's add down. When we add these 2 together, we get 0, don't we? Okay, so we add down, we get 0. Plus, something weird is about to happen. Negative 3y plus 3y, that gives us a 0 again, right? and then equals, and we add down here, these two added together give you 22. So you get 0 equals 22. What? 0 doesn't equal 22, right? Something seems wrong here. Right? When we did this last time, what we were getting was like the x's would go away, but we would still have y's. Or the y's would go away and we'd still have x's. Here, everything went away, and look at the final statement. The final statement we have is 0 equals 22, and 0 does not equal 22. So what do you think is going on here? Think about this geometrically. Remember when I introduced this last class? What 2x minus y equals 5, if geometrically, what is it? What is it? A line, right? So this is a line, right? And then this one right here is another line. Okay? And what we're trying to find is the solution, which would be what? Geometrically, where the two hit each other, right? And so we're trying to find the point where the two lines hit. And as we're trying to do it, we're getting a statement that doesn't make any sense. What do you think that means about these lines? They're parallel, they don't touch. Okay, these lines are actually parallel. And we know that only because we get something that doesn't make sense at the end. So what are we going to say here? We're going to say this right here tells us we have no solution. There is no solution to this system of equations. And I said that that is possible last class. Shall we look at it geometrically? Let's graph it, okay? Because I want us to see it to verify it. Okay, so I'm going to put in here 2x minus y equals 5. And then negative 6x plus 3y equals 7. And look at that. When I graph the two lines, you can see that they are parallel, right? Which means there's no intersection, which means there's no solution. Okay? So just be careful because, you know, last time, every time we did this in last class, we got an answer. We got an actual point, an x and a y. Here, the thing that tells you that we have no solution is the fact that we get some nonsense here at the end, right? We get this nonsense that 0 equals 22, all right? Okay, but that was an interesting one to pick first, but it is what it is. Let me look at another one here. Okay, so I'm going to make one up because I want it to do something in particular, all right? So how about we do this? How about we have negative 2x plus 5y equals 4. And then how about 6x minus 15y equals negative 12. Oh, I see what happened. Okay. Right. Trying to solve this system of equations. So let's do elimination again. Okay, let's do elimination. We are going to let's try and get rid of the x's. So if I'm going to try and get these x's to cancel, what am I going to have to do? Multiply by 3. Just coincidentally, it's 3 again, right? Because if I multiply that by 3, I'll get a negative 6x. That'll cancel with that. So let's do that. We get 3 up here. We're distributing through. And so we have a new system. It'll be negative 6x plus 15y equals 12. And then the bottom equation, I don't touch it, right? I leave it alone. 6x minus 15y equals negative 12. Something weird's happening here as well, right? Do y'all see it? You add these down, you get 0 again. Plus, let's see, you add these down, you get 0 again, so plus nothing. equals, and then now on this side, 12 take away 12, you get 0. So now look at your final statement, 0 equals 0. That's actually true, isn't it? In the previous one, 0 equals 22 doesn't make any sense, but 0 equals 0 makes sense, right? It is, right? 0 is 0. So this is true. What do you think this means? So, okay. Yeah, so remember the previous problem, they were parallel, right? So they never hit each other. Danielle, is that a question? Yeah, there's an infinite number of solutions, which means that these two lines are the same line. It's the same line, which means they hit at every point. All right. And the thing that lets you know that is at the end, you get something that makes sense. So if you're working through a problem, you get like 3 equals 3, then you know it's this situation. If you get 4 equals 4, you know it's this situation. But if you get 0 equals 4, then there's no solution and they're parallel, but they're different lines. Okay, so this would, we would just say infinite solutions here. Solutions. And I'll just put on the side here, just so we know. It means that they're the same line. Okay. So I've shown you now in this class every possibility that could happen. Last class, it was all about we'd have one solution. This class, I've shown you the other two scenarios where you have no solutions and where you have an infinite number of solutions because it's the same line. All right, I want to do one more before we get into the word problems. I wanted to do one with fractions, because you all love fractions, right? Okay, so how about this one? Sometimes we can't avoid it. We did have to deal, last class, we did deal with systems of equations that had decimals in them, right? When we were doing the mixture problem, there were decimals. And in the homework problem, the homework problems I gave you, there was the last problem had decimals. No, 2 problems I believe had decimals in it. Fractions. You have a couple of choices. One thing you could do first, if you don't like the fractions, is just get rid of all of the fractions before you even begin trying to solve the system. So like if you don't like this 1/3 here in this first equation, we can just multiply that entire equation by 3. And that will have the effect of getting rid of the 1/3. And then on the bottom, I want to get rid of the 2 and the 3. So what would I have to multiply across here by? 6. They're the least common multiple of those two numbers. So basically clear the fractions. Is that all right if I do that first, just to avoid fractions? Okay, let's do that. Let's multiply the top equation by 3, the bottom equation by 6, and we'll distribute through. Just remember that these have to go through to all 3 pieces, right? So our new system is what? What's our first equation become? 9x plus, well, it's 3. The 3 comes and hits the 1/3, and the 3's cancel, so you're just left with y, aren't you? That's the whole point, is to try and get rid of that fraction. So we have y there, and then equals what? 9, good. And then on the bottom equation, distribute through. I look at it this way. When I hit this 6½ together, I think like, what's half of 6? Or just put the 2 into the 6 and you get 3, right? So 3x. And then on the next one, what will we have? Minus 2y. And then equals -6, because you're multiplying -1 times 6. Are there any questions on that? That's okay, everyone? All right, this is a little easier to look at, right? This is a little bit nicer to try and figure out. So what would y'all like to do? Would you like to try and kill the x's or kill the y's? Do you care? You want the x's? Okay, so if you were going to do the x's, what would you multiply? Which one would you multiply by 3? The first equation or second? Second. Okay, if you multiply 3 out here, 3 times 3 is 9x, and 9x, that'd be 18x. So -3, right? Okay, so does everyone agree you could do -3 right here to here? That's if you wanted to kill the x's. What if you wanted to kill the y's? Times the top by 2, because then that would become 2y and minus 2y. It's your choice, right? You get to choose. So what do y'all think? How many of you want to kill the x's? Y's? Okay, we got more y's. Let's go with y's. If you want, you can do the x's. If y'all want, you can do the x's, and you can see we'll get the same answer. But I'm going to kill the y's. So I'm going to do 2 here. Boom, boom, boom. That will give me a new system of equations. I'll put it right below here. It'll be 18x plus 2y equals 18. And then I have 3x minus 2y equals -6. And now we can add these down. And when we add down, what's that? 21x. The y's add up to be 0, right? When we add down there. And we add down there, 18 take away 6, positive 12, right? So we have, at the end of this, 21x equals 12. So now what we can do is we can just divide both sides by 21 to get what x is. So x will be 12 over 21. Does that fraction reduce? What goes into both of those? 3, right? So 3 goes into 12 4 times. 3 goes into 21 7 times. So x is 4 over 7. So we know what x is, right? We just don't know what y is. So how do we get y? Plug the x back into where? Any equation, any of them. You get to choose. There's no restriction here. Now, I personally don't feel like playing with fractions again, right? So if I'm going to plug in x, I'm probably going to plug it in. I don't know. To me, this looks like maybe the nicest one, right? So that's the one I'm going to choose. But you can pick any of them, okay? Doesn't matter. So I'm going to now substitute. I'm going to take let's take this one right here. 3x minus 2y equals -6, right? And we're going to replace that x with 4 over 7. So look, unfortunately, we're not going to be able to avoid fractions. We avoided fractions in the solving, but our answer is a fraction. Because, so when we plug it back in, well, we've got fractions, all right? That's life. Deal with it. So we have 3 times 4 over 7 minus 2y equals -6. Make this a little bigger. That's kind of hard to see, isn't it? Now, when I multiply this, I multiply that 3 across the top, right? So that's just going to become 12 over 7 minus 2y equals -6. And now we have to solve this for y. So we have plenty of options here as to how to do this. You could clear the fractions if you wanted to right now, multiply everything by 7. And you would no longer have fractions, or you can actually play with fractions. So what do y'all want to do? Do you want me to clear it, or do you want me to just move things around? You want to clear it? Okay, I'm going to clear it then. My thing broke. Oh, here. Oh, yeah, just enough. All right. So we're going to multiply both sides by what then? To clear that fraction. 7. So 7 over here, 7 over here. When we distribute the 7 through here, the 7s cancel, we get 12. 7 to here, we get -14y. And then the other side is -56 because -6 times 7 is -56. And now this is just a linear equation, right? We can just move things around. Wait a minute. 42. So that's, I can tell that look on your face. Oh, wait a minute. That's arithmetic, right? Okay, there we go. All right, so we'll subtract 12 on both sides. We get negative 14y equals, what's this, negative 54. And then divide by negative 14. So when you divide both sides by negative 14, let's see, a negative divided by a negative is positive, right? So that'll be a positive answer. 2 goes into both of those, right? Sometimes they go in the top one. 27. And then on the bottom goes in 7 times. So y is 27 over 7. So if I were to write this as a point, if somebody could get on your calc, well, I might have, where's? Oh, I had it. Let's just get that as a decimal. Because I'm going to graph it. I want to show you the graph of this. 4 divided by 7. So this is really like 0.571, and 27 divided by 7 is about 3.857, something like that. Okay, so what should happen is if I go graph these 2 lines, then when I go to this x coordinate and this y coordinate, I should see the 2 lines hitting each other, right? That's what should happen. So let me try that. Any questions while I'm graphing this? I need my lines. Okay, my first line is 3x plus y over 3 equals, what was it? Equals what? Equals 3. My goodness. And then it was half of x, right? Minus y over 3 equals negative 1. Okay. So there's the graph. Okay. And if I hover over this, it will show me where they hit. Can you all see that? 0.5, whoa, come on, 0.571 and 3.857. So it, like, really in the real world, if you were truly trying to solve this system, this would be a very useful tool, right? You could just type in the equations of the lines and just come to the software and just hover over and you get your solution. I think the word problems we do right now, we could probably check our answers this way. And then I think you would see, like, outside of a classroom, you would want to do it this way, right? All right, let's do it. Word problems. So what I'd like to do is I'm going to put up the first word problem, okay? And then I'm going to have you think about it and see if you can come up with the system of equations for it. Don't solve it. You know what? I'm going to take both of these. See if you can come up with the first 2. Why is this going so slow? There we go. I'm going to give you, so can you all see that okay? Can you read it enough? No. Look at the first one. An animal shelter has 105 cats and dogs. They have 15 more dogs than cats. How many dogs do they have? How many cats do they have? Think about it. See if you can come up with the system. I'll give you a hint to help you. Let X be the number of dogs you have. You don't know how much that is. Let X be that, and let Y be the number of cats. All right. So when they say, how many dogs do you have? Let's let that be X. And then how many cats do you have? Let's let that be Y. And then from that, see if you can create an equation off of two equations. You're gonna need two separate equations off of the information. If you have them, let me raise your hand. I want to just come by and see. Yeah. All familiar. Okay. The first one, I think that's the second one. Think about that. Think about it. You see? All right, let's do the first one together because I think maybe some of you are hung up on this one. So you have an animal shelter, right? You have 105 cats and dogs together, right? So if the number of dogs you have, X, plus the number of cats you have should be 105. I think most of you got that part, yes? The total number of dogs and cats together is 105. The other piece of information that's important here is that you have 15 more dogs than cats. 15 more dogs than cats, right? So you need to somehow create an equation out of that. So here's the way that I think, if you're having trouble coming up with that equation, here's the way I would think about it. Let's say that there were 5 cats. How many dogs would you have? Well, then that wouldn't work, would it? But because there's two things. If I say there's 5 cats, right? Well, if I say there's 5 cats, there's 15 more dogs, right? Which means you would have 5 cats and how many dogs? If I say there's 5, forget this, okay? Forget this. Just read that sentence alone in yellow. If you have 5 cats, according to that, how many dogs would you have? You have 15 more dogs than cats, right? So you'd have 20 dogs, right? If you had 10 cats, according to this, how many dogs would you have? 25. Does that make sense? If you had 20 cats, how many dogs would you have? 35. So what if you had Y cats? How many dogs would you have? 15? No. So if you have 5 cats, you're taking 5 and you're adding 15 to it, right? For the number of dogs? Y plus 15, right? If you have Y cats, then you have 15 more dogs. So you should write something like this down. Y plus 15, right? Y plus 15 is how many dogs you have. So if I had 5 cats, I add 15, right? I'd have 20 dogs. If I have 10 cats, I would have 25 dogs. Does that at all make sense to you? You have a question? No? Now, look, this equation by itself, there's an infinite number of solutions. You could have 2 cats and 17 dogs. You could have 5 cats and 20 dogs. But the thing is, we have to have a total number of animals of 1 and 5. So we have to figure out an X and a Y that solves both of these at the same time, right? But those are our 2 equations. So we need to create the system now. Are there any questions off of the 2 equations? All right, let's create the system. So I'm going to write the first equation, X plus Y is 105. And the other one is Y plus 15 equals X. Now we have an issue. The issue is that if we're going to use elimination, right, which everyone seems to have brought into elimination, the key for elimination is that when you start the problem, your x's have to be lined up, your y's have to be lined up, and then you have to have a number over here, right? That's what you have to have. So I need to move this x over to this side and the 15 over to this side. So I'll subtract x to move it over here, and I'll subtract 15. So in other words, I'm taking this equation up here, I'm subtracting x on both sides. I'm subtracting 15 on both sides, so that the x's go away here, the 15 goes away there. I get negative x plus y equals negative 15. That should be my second equation. So this system becomes x plus y equals 105. And then negative x plus y equals negative 15. Now check, we are ready to go with elimination, because we've got our x's lined up, our y's lined up, and then our numbers lined up. Do we need to do anything to kill off the x's? We don't, right? We have x and negative x, so we just add down right now, and we don't have to multiply through by a number. Isn't this nice? Add down, add down, add down. So the x's cancel, we get nothing. Plus we'll have 2 y's. And that must equal, let's see, 90. And now you divide both sides by 2. So take 2y, divide by 2, take 90, divide by 2, and you get an answer, y is 45. Once you know what y is, you can plug that answer into any of these equations you want. Anyone. I like this one right here. See that one right there? Y plus 15 equals x, because that already has x solved for, right? You already have x by itself. So here, y plus 15 equals x. So if we plug in 45 for y, we get, what is that, 60? There are 60 dogs and there are 45 cats. We can check the answer. We can just think about it. How many animals are we supposed to have total? 105. Is this 105 when we put that together? Yes. We're supposed to have 15 more dogs than we have cats. And we have 60 dogs and 45 cats. So we have 15 more dogs than we have cats. All right. Look at the next one. Make it a little bit bigger. Maybe I can't. There were 429 people at a play. Admission was $8 each for adults and $4.50 for children. The total receipts were $2,641. How many adults were there and how many children were there? So they're asking us for two things, right? How many adults, how many children? So that's what X and Y should be, right? The number of adults should be, we could let the number of adults be X. I'm going to be a little more formal here the way I do this. I'm going to say X is equal to the number of adults, right? And let's say Y is equal to the number of children, right? Just so we've established what the two variables mean. So can anybody give me the first equation? Go ahead, Danielle. X plus Y equals 429. Can you explain why? The total number of people, right? The total number of people at the plant was 429. That 429 includes both the adults and the children. So when we add up the total number of adults and children together, we should get 429. That's our first equation. Great. Now we need the second equation. The second equation, I'm going to do it on the side over here. we'll put them into a system after we're done, comes from the cost, right? So think about it. It was $8 for an adult and $4.50 for each child. So if we had 10 adults, let's just say we had 10 adults, how much would we have total from the adult admission? 80, right? All you're doing is you're taking the 8 and multiplying by 10. If we had 20 adults, how much would we have from the adult admission? 8 times 20, right? 160. So what if we had X adults? How much would we have? So if we have 10 adults, it's 8 times 10, right? We have 20 adults, it's 8 times 20. If we have X adults, it's 8X, right? So we know that the admission we get from the adults is 8X, right? But then when we have to add to that the admission from the kids, right? And the kids is $4.50 each. So if we had 10 kids, it would be $4.50 times 10. If we had 20 kids, it would be $4.50 times 20. So if how many kids do we have? We have Y kids. We don't know, right? We have Y kids. So it's going to be 4.5 times our $4.50 times Y, right? That needs to add up to be what? The money that we brought in, right? $26.41. There we go. So we have two equations, so we can create the system now. So the system will look like this. X plus Y, come on, man. X plus Y equals 429. And 8X plus, I'm gonna put 4.5. I don't need the 0. 4.5Y equals 2641. All right, are the X's lined up? Yes. Are the Y's lined up? Yep, numbers, great. Now I do have a decimal. Let's deal with the decimal. How can I make that a nice number instead of 4.5? I can make it a 45, right? But I would have to move the decimal point one place to the right. If I do it here, I've got to do it here and here as well. So instead of having 8, I'll have what? 80, right? Instead of having 2,641, we move it over. We'll put a 0 there. It'll be 26,000. All this is doing is helping us have nice numbers and not have to use decimals. You all right with that? So I have 8X plus Y. I'm sorry, what the hell am I doing? X plus Y. X plus Y equals 429. So essentially what we're doing is multiplying by 10. That has the effect of moving the decimal point over 1. So I'm going 10 here, 10 here, 10 here. And so we get 80X plus 45Y equals 26410. All right, now that all we did that for was to get rid of the decimals. All right, that's it. You don't have to do that step, but you know, why not? All right, you want to kill the X's off or the Y's? I think it's equal. It's about equal in terms of what it's going to take. So what do you want to go for? You want to get the Y's? Okay, if I'm going to kill the Y's, what am I going to have to multiply by? Negative 45 on the top equation, right? Top equation, negative 45. It's got to go through to everything. Oh. Okay, our new system will be negative 45X, negative 45Y, and then you probably need your calculator. What's negative 45 times 429? Negative 19,003 what? 05, okay. And then here we have the bottom equation, 80X plus 45Y equals 26,410. Add down. Those go away. We should just get 35, right? 35X. Because you take negative 45X and you add 80X, you get 35X. And then what's the other side become? when you take the 26,410 and take away the 19,305? 7,105. Okay, thank you. And now we'll just divide both sides by 35. Is it a nice number? What is it? 203. So this step, all I did was divide both sides by 35. So X is 203. And this is the number of adults, right? X was the number of adults. So to get kids, we can go into any equation we want. Which equation looks the nicest to you? X plus Y is 429. It's probably the one to go with, right? Let's take that equation. Let's write it down. X plus Y is 429. And let's replace the X, right, with the 203. So that becomes 203 plus Y equals 429. Subtract 203 from both sides. What do you get? 226. And this is the number of kids you have, children, whatever. So if we add this up, we should get 429. And then if you take this number and multiply by 8, and this number and multiply by $4.50, add that together, you should get the, what was the amount? $2,641. Y'all see how this is working on these problems? You're always looking for two things, and you're always going to have two equations, and then you have to solve the system. Let's look at the next one. You have a total of $180. You only have $5 bills and $10 bills. And you have 9 more 10s than you have 5s. How many of each bill do you have? How many of each bill do you have? So the way I'm going to let you try and set this up, but I'm going to just tell you, first thing you should do is tell me what X is and tell me what Y is going to represent. All right. And then go try and set up your two equations. Go ahead. I'm going to go get a drink. So see, if you can set up the system, go try and solve it. And don't be afraid to ask your neighbor if you want to see if they'll have the same thing. Progress or no? I'm gonna start just like silently working it out here. Did everyone do X is the number of fives and Y is the number of tens? Yes, okay. You could have done it the other way around if you wanted to. So this is the number of $5 bills you have. And this would be someone want to give me the first equation that they got? X plus Y is 180. You sure? So X is the number of fives you have, right? So if X is 1, you have $5. If X is 2, you have $10, right? If X is 3, you have $15. So think about it. If you say X plus Y is 180, right? Aren't you really telling me then that the total number of bills you have is 180? Like you have 180 bills in your hand, right? That's what that means, right? So we would have to have what instead? How many of you did X plus Y is 180? It's okay if you did, no? Yeah. So, all right, so who wants to share what equation they used? What did you have? 5X plus 10Y is 180. Think about that. Does that make sense? X is how many fives you have. So if you have 1 5, this will count $5. If it's 2 5s, it'll be $10. 3 5s, it'll be $15. Y is how many tens you have. So if you have 1 Y, it's $10. 2 Ys, it's 20. 3 Ys, it's 30. That makes sense? That means the total $180. That's your first equation. The second equation comes from this. You have 9 more tens than you have fives. You have 9 more tens than you have fives. That means however many fives you have, right? You have 9 more tens. How would I write that? X plus 9 equals Y. Let me write that down. X plus 9 equals Y. So X is what? X is the number of fives you have, right? If I add 9 to that, that's how many tens you have. So Y is the number of tens you have, right? This will be 9 more than the number of fives you have. So this is right. Everyone follow that? Now I already know that if I'm going to do a system of equations, I'm going to need to move the Y over here and the 9 to the other side. So I'm going to subtract Y on both sides and subtract 9 on both sides. I'm doing that just so I can set up my system. So I have 5X times it plus 10Y equals 180. And then X minus Y equals -9. There it is. I like the idea, me personally, in solving this system, I like the idea of multiplying the bottom equation by 10. Only because this will turn to a -10 and these Y's will cancel. That's not the only thing you could do. You can multiply the bottom equation also by -5 and make the X's go away. But I'm gonna do +10. Why? I don't know why, because that's what I feel like doing. So here, here, and here, my new system becomes 5X plus 10Y. Are there any questions? Equals 180. Y'all are good? 10X minus 10Y equals -90. Add straight down, the y's will cancel. That was why we did it. 15x equals 90. 180 take away 90 is 90. And then divide both sides by 15. What's 90 divided by 15? 6. So x is 6. X was the number of what? 5s we had? So this is how many $5 bills we have. The number of 5s. And then to get y, I can go to any equation I want, right? Any equation I see on the page. I like this one in green. I like that one because it's already solved for y, isn't it? Like it has y by itself already. And I know what x is. So I'm going to use that one. X plus 9 equals y. And I know x is 6. So 6 plus 9 is y. So this is 15 is y. This is how many 10s you have. Shall we check it just to make sure? Questions or no? Yes. I remember you're adding down, right? So you're doing 180, take away 90. So think about it. This is money, right? This should be easy for us to think about. If you had 15 10s, that'd be 150 bucks, right? And then we had 6 5s. 6 times 5, that's 30 bucks. 150 and 30, that's 180. So we have $180 in our hands. Also, we have 15 10s and 6 5s. So there's 9 more of these than there are those, right? We only have 6 of these bills. We have 15 of those bills. Okay, we all right? This reminds me of something. It's not related to systems of equations, but I remember growing up. Have any of y'all ever eaten at that Chinese restaurant on Broadway called Ding Hao? Or no, not Ding Hao. Hung Feng? Hung Feng? No. Okay, it's like it's been around forever. Okay, so I can remember as a kid going there, and at the front of the restaurant, when you check out, they had a plastic little tub, probably like the size of a little small fish bowl, filled with Chinese candy. Y'all know what Chinese candy is? It's like dried plum with salt. They were like individually packaged. Actually, back then, I don't know if they individually packaged them. I think they put them out with little prongs and then put them in a paper bag. But anyway, on the front of this thing, there was a little sign. And here's what the sign said. I'll make it big so you can see it. The little sign said this. Oh, no, sorry, that's not what it said. It said this. Okay. So my dad goes up there and he asked the lady that's behind the counter if she has more Chinese candy than what's in the bowl. Like, is this all you have or do you have more? And she like goes into the counter, she pulls out this big old bag. And, you know, there's this huge bag of Chinese candy. And he's like, I'll take everything you have. And she's like, okay. She's like thinking about how she's going to add it up, right? To give him the Chinese candy. And he hands her $1. And she's like, oh no, it's going to be more than that. He's like, no, it won't. It won't be more than that. So what does this mean? Does not mean 5 cents. So this is what they had written, right? This means 5/100ths of a cent. So if I write this, if I write 5 with the cent symbol, that's a nickel. Okay, that's a nickel. That's what a nickel is, 5 cents. If I write this, a dollar sign in 0.5, that's $1, but you're taking, this is tenths, this is hundredths, this is 5/100ths of a dollar. A penny is 1/100th of a dollar. So this is 5 cents as well. These are the 2 ways you can write 5 cents. This is 5/100ths of a cent. So basically it would take, what this means is that for this to become 1 cent, I would need 20 of these. So basically 20 Chinese candies cost a penny. Okay. And so my dad handed her $1 which would get him 500 Chinese candies, right? So this was a mistake on their part. He was just making a point, so they fixed the sign, right? I don't know why. Anytime I deal with dollars and stuff, I always think of that story. My dad, from a very young age, my dad was always trying to teach me lessons. But okay, y'all ready to look at another one? We've got 15 minutes. Let me read this one. Okay, that one's, I don't think that's something I would give you on a test. So let me get to the homework problems. Why don't we look at a homework problem? Ooh, let's try number 12. I like number 12. Now, this is a homework problem, so you're getting a little bit ahead of yourself here, getting this done here in class, but there you go. On a farm, there are pigs and chickens. There are 7 more pigs than chickens, with a total of 58 feet. 58 little feet total. How many of each type of animal are there? I'll give you some time. What's X and what's Y? Always start by putting down what it is that you're looking for. That's given in the question, right? How many? This problem does assume you know how many feet a pig has. What are y'all letting X and Y be equal to? I'm saying in terms of what is the X? Is it the pigs, number of pigs you have, or you did pigs and chickens? So X was pigs. This is, you did the opposite? Okay, it's all right. Just, yeah, I mean, it's okay as long as at the end you state how many, like if you get an answer of 2, 2 what? Make sure you put that in your answer. So X equals, you said we're doing number of pigs for X and number of chickens for Y. Who has our first equation? Who wants to give the first equation? One. Tell me about the feet. We need 58 feet total, right? Little feet, little feet. X plus Y, 58. That would mean you have the number of pigs together with the number of chickens added would be 58. We don't want that because we're talking about feet. Go ahead, Danielle. So a pig has 4 feet, right? So we're going to say 4 times X would count how many feet we have for the pigs, plus the chicken has 2 feet, right? So 2 times number of chickens we have, that should add up to be 58. Do you all see that this is exactly the same problem as the one we just did with dollar bills, except 5s and 10s, right? We had number of 5s, number of 10s. So for each $5 bill, we multiply by 5. For each 10, we multiply by 10. Here, because we're talking about chickens, chickens have 4 feet. Sorry, pigs have 4 feet. Chickens have 2 feet. So we put this together, and that must equal 58. Good. That's our first equation. And then the other one has to do with, we have a certain number more. So there are 7 more pigs than chickens. So y plus 7, right? Y plus 7 must be how many pigs we have, right? Does that make sense? There are 7 more pigs than chickens. So however many chickens we have, we add 7 to that, and that gives us the number of pigs. We're going to need to move things around here, aren't we? Now, when you move things around, it doesn't matter which way you go. You can move the y over here, or you can move the x to the left and then the 7 to the right. It's your choice. So I'm just going to move the y to the right and just make this 7 equals x minus y. And now I'll set up my system. So my system looks like this: 4x plus 2y equals 58. And then the other one is x minus y equals 7. Does anyone have a solution yet? What did you get? So y equals 5. So this is your pigs, right? X was pigs and chickens. I'm not showing the solution. I'm not showing the work to solve this, but I will mention what it is we did. What did you do, Raymond? Did you kill the X's or the Y's?
I killed the X's.
The X's, so you multiplied the bottom one by what? -4. You could also multiply the bottom by 2, just 2, and you would kill the Y's off. So look, I'm not showing this work, everyone. I'm leaving it to you to solve that system on your own, but you should get 12 and 5. Should we check Raymond's work here? Right. You have 7 more pigs than chickens, right? And then a pig has 4 feet. So 12 times 4 is 48. Chickens have 2 feet. So 5 times 2 is 10. So there's 48 feet and 10 feet. That's 58 feet total. All right, here's your homework assignment. So last class, or actually I should say on Monday, I emailed the class the system of equations problems to do. That's due when you come into class on Thursday. All right. So beginning of class, turn that in for a quiz grade. And then what I'd like for you to do, this is out of the packet. Let me see how many of these I want you to do. Let's do those right there. So look, if you'd like, I'm just going to leave this up here. You can come up, take a picture, or you can, if you can take a picture from your, but remember, I will send these out to y'all later. Okay, I'll send these to you, but if you want, just take a picture now, and that'll be due, not on Thursday. Let's make this due on the day of the test, which is Tuesday, right? So the 26th, this will be due to turn in. And that's all we're going to do today. So if you would like, you can hang out if you have any questions about anything. I can go through something with you. Next class, remember, I'm going to start some new material. We're actually going to go back to the beginning of the semester and start talking about some things like stuff we skipped over, conversions and scientific notation, some ancillary stuff. And then we'll talk about the test. So be looking in your email for later today for these problems and for the review for the test. All right, everyone, have a good day. I'll leave that up in case you want to come.
These problems are out of the packet.
If you want to look in the packet, I believe this is page is this? 214. Which ones did I give? 13 through 17? Is that what I had up there? 14 through 17. There we go. I'm going to take a picture myself.